Hi, welcome to section 12.1, inverse functions. Hopefully by the end of this you all will be able to identify one-to-one functions and find the inverse of a function. So let's talk about one-to-one functions. In a one-to-one function, every single x goes to exactly one y. It doesn't go to more. And every y goes with exactly one x value. So graphically or visually, they're going to pass the vertical line test and the horizontal line test. So that means every vertical line that you could possibly make goes only through one point, and every horizontal line that you could possibly make goes through exactly one point and not more than one point. Alright, so let's do an example. We're just going to determine whether each equation represents a one-to-one function. Okay, so this is example 1. The first one I have for us is y equals 2x minus 1. Alright, so let's talk about the x's to y's first. So for every x value, does it go to one y value? If I plug in an x value, it doesn't matter which one I use, but I would multiply it by 2 to solve for y. So that would just give me one value. Then I would take whatever I get and I would subtract 1, which again would only give me one value. So I would only get one y value. So that's good. Alright, what if I start out with a y and I need to solve for x? If I start out with a y, I would add 1 to both sides, so then that would just give me one value again. And I divide both sides by 2, which again would only give me one x value. So that's good. Visually, you guys probably might know what this looks like. Y equals 2x minus 1 is a diagonal kind of a line. It's about like that, where the slope is 2 and the y-intercept is -1. So you might know kind of what that looks like. So the vertical line test, every vertical line you could possibly make just goes through one point. Every horizontal line that you could possibly make just goes through one point. So it passes both of those tests. So this is a one-to-one function. Okay, so there's kind of the algebraic way to look at it. There's the kind of visual graphing way to look at it. Okay. The next one I have for us is y equals negative x squared, or the opposite of x squared. Okay, well, let's check them both ways. So if I start out with an x value, whichever x value I get, I would square it first. And squaring things only leads to one value. You know, if I started with, x is 1, for example, I'd square it and I would get 1. Then I would get the opposite of that, which would give me -1, and that would just give me one y value. Okay, so checkbox. What if I start out with a y value? Oops. If I start out with a y value, well, I would divide that y value by -1 first. So probably starting out with negative y values to get nice real numbers here. But you take that y value, you divide by -1, and then to get rid of that squaring, I would take the plus or minus square root, right? So I would take that y value, I'd divide it by -1, right? And then I would take the positive or negative square root to solve for my x. That positive or negative square root means that I would go to two different x values, because I would have a positive version and a negative version. Okay? Visually, you might know what these look like because we just finished graphing quadratics not that long ago. This is a quadratic equation. It has a negative coefficient, so it's going to be a parabola that's going downward, kind of like that. So the vertical line test is going to pass just fine. Every vertical line just goes through one point. The horizontal line test is what's going to give us more of a problem. That's where this comes in. Lots of horizontal lines go through more than one point, right? So it fails the horizontal line test pretty miserably. So this one is not a one-to-one function. It is a function that passes the vertical line test, but it is not one-to-one. Now it's your turn. You guys get to try one and show me how much you've learned.